The steps we took in parts 1 and 2 have now put us in a good position to start animating this clamp mechanism. We put together some rack and pinion mates and we place the spring internally into this assembly. The spring is a part, but the part only exists within the assembly. There's a few more steps we can take before we actually go into the animation. So let's have a look at a master file we actually put together to model up the parts in the first place. So although this looks like an assembly, it is actually a part file full of solid bodies. Now to start the file, I put together a couple of template sketches. Now we can go straight into template sketch 1, and this is going to give us some information we need in our assembly to tell us how far to move our rack and pinion. So the gear is going to have to move 60 degrees, and the 10mm diameter mid circle is we're going to have to find the actual length of the arc to decide how far the rack is going to have to move. So let's just delete some geometry and let's ignore the fact that it's just going to over define it. This is okay, we're not particularly interested in that fact. So the arc that I'm interested in to tell me how far my rack is going to move, let's just go to evaluate and measure. Let's measure the length of the arc. So it confirms that the radius is 5mm, the angle is 60, and the arc length is 5.2359 millimeters. So let's copy this, and then we can come out. And that's all we wanted from our master model. Okay, so now we're back in the assembly. Actually, no, we're not. Let's close it. Okay, now we're back in our assembly of parts. So I want my rack to move by a set distance. I've just noticed that I have a mate that's still turned off. So let's just go. Yeah, let's turn the camera off because the camera angle changes can be quite annoying. So in the motor mate, I want a linear motor in my animation motion study. I'm going to pick my component. So I'm going to pick the base of this rack. And I wanted to move it down, but I want it to move at different sections of the animation. So I don't want to go with constant speed. I want to go with segments. So I'm going to segment when it moves down. So I have a series of positions. Let's add a row. So from 0 to 1 second, I don't want the part to move at all. Now let's add another row. Now from 2 to, let's say, 6 seconds, I want it to move, and let's go paste. So this is Control V, which will give me a paste from my model. 5.2359 we've added. Again, that's come from the master model. From 6 to 10, I want it to stay there. So it's going to be there. And then from 10 to 14 seconds, I want it to go back to its start position. So I'm going to put it back to 0. So the graph showed the displacement. So there's no displacement until 2 seconds. And then it moves, and then by 14 it comes back to its start position. And the velocity, see, increasing velocity as it moves, and then at 10 seconds when it moves back, you can see a sudden increase in velocity. We also have acceleration and we've got jerk. We won't worry too much about these. So I'm happy with the motor. So I've basically set the motion for the rack. I need to find this mate I was talking about earlier. So there is a mate. There you go. That's the backstop mate. So let's come out of the study and let's turn that mate off. Coincident 8. And that was just to align the geometry in a previous video. And I can see it's back on when we go back in the motion study, so let's turn it off here as well. Okay, so I want the timeline to be 14 seconds in line with what I've just put in for the motor. We're on animation as the type of study. Let's put in a standard view. And when we run the analysis, you can see everything's gone a little bit awry, but this was kind of expected when we put together the rack and pinion mate. So it is purely the rack and pinion mate that I need to look at. So let's look at the second rack and pinion mate. And just by reversing it, no, reversing it doesn't work, or selecting a different line from the rack might cure this part. So let's get rid of the edge. And let's use the same edge that we're referencing from the first rack and pinion. Let's see what that does. So let's process the model. Looks promising, looks like everything's moving the way I want it to. 10 seconds it moves back. So between 10 and 14 it's moving back. Okay, so let's get a better view of what we've put together here. And I've got the gears and everything moving together. And then from 10 seconds moving back out. Brilliant. Okay, I think that's working for me. And now let's have a look at the spring just to confirm this is working as intended. Okay, so the spring looks like it's working out as well. So let's have another look. Let's just run it. We can slow it down, but I'm not going to. Let's play it again all the way through just to check everything is coming together and moving as intended. No clashes. And that's it. That's how you set up and run a basic animation for a clamp mechanism with a spring